target value is no or yes. Upper level is gonna be 1, lower is 0. So we predicted negative values correctly. This is how the CSV file bank looks like. This is like a copy from a text file. That's why these looks like separated from each other with semicolon. We're just telling our code then that first row is going to be header, because the first row in this Excel file was header, and the limiter, the sign that splits our columns, is semicolon. So we already said this. This is first 5 rows of our data. If we say give us some sample rows, 5, okay, just different 5 rows. All right, so far so good. All right, for logistic regression, our target value is, for example, here y value, but these are no or yes. So linear regression, we had a linear function which looks like ax plus b. For logistic regression, we want to say our target, we want to say our prediction is either 0 or 1. This is in the binary case. So if we have our values are like this. So for example, we drove a linear regression line. For example, that's the best fit. So we did some mistakes. We couldn't predict these values as correct. So what we are looking for is something like this. What we want to say, for example, upper level of this graph of this curvy line is gonna be 1, and the lower of this curvy line is gonna be 0. So the function, our function called sigmoid function, let's say sigma ax plus b. You remember ax plus b, it's coming from linear regression, equal to 1 divided by 1 plus exponential ax plus b. So this function gives us some numbers between 0 and 1. And now logistic regression works. For example, if we get something big larger than 0.5, we will gonna say this is gonna be equal to 1. If we get something less than 0.5, we will say that's gonna be 0. So this is how predefined logistic regression function inside Python works. So as you can see, now we have some text values here, like marital status, education status. But what we want is numbers, so we cannot put all these variables into a formula. So there are 2 methods. The first one is label encoding. So with label encoding, first we are from sklearn preprocessing module, we are importing label encoder classifier. And then we are creating an encoder, label encoder object. We call this encoder. All right. So let's encode these two education and job data. So right now, as you can see, for education code, we have for each different value, we have a different number. So for job, for example, we had different jobs over here, and for each job title, we have for each unique job value, we have a number over here. These are based on the alphabetical order, so not really complex. Again, let's observe a sample. I want to see how different variables we have. So as you can see, it might go up to 11, and education code, I think it's just 0, 1, and 2 as far as I could see. Now these are the new titles for these. For example, education is still here, but we have a new title which is called education code. If I delete this and just make it same, then education is also gonna be in its original place. The other one is called one-hot encoding. So this time, this is going to create, for example, if I'm a blue color or not. So we're gonna create some dummy columns, and it's gonna have only 1 and 0 values. If I have a college diploma, that primary school column for me is gonna be 0. So let's go back to original data with all the number with all the text instead of having the numbers. Here we are creating a copy of the data because we don't want to make some changes in data. Sometimes when you use assignment method, when you just put the data here, it also makes some changes in data. So I just want to be sure, that's why I'm just creating a copy of that data. And now the second method, I'm calling get dummies function from pandas, and I'm taking copy data, I'm taking education column, and I'm gonna say the new columns have going to have a prefix education, and the same thing for job. The job columns are going to have a prefix job text. All right, when we look at that, the prefix is job, and this is 0 or 1 based on the job title we are holding. So we cannot even observe the education's one because there are a lot of different job types. Let's come here. All right, so for us the target value was negative, the last column of our data. So here again, I don't know how many different job and education column we created to be able to estimate that we are counting the different values, unique values in this data sets by using value counts.count. You can also use other stuff, for example, creating another data set with unique function, and then you can find the size of this data set. There are a lot of different choices you can have, and then let's say when I print n, it's going to print me the number of columns, dummy columns we created, and then what I want to say, our x is gonna be the whole rows, and I only want to consider the last 16 columns. This is what it means. Starting from the last 16, go up till the end of the to the last column. So I would like to include education level and job type. Also, I would like to include third and the ninth column into my regression. So third column is gonna, here it's balance, and the ninth column is the third, fourth, fifth, sixth, 7, 8, and 9, and the duration. Alright, so this is, right now I'm going to concatenate x value, and I'm also going to have third and the ninth column with all of the rows. If I'm concatenating but by saying x is equal to 1, it's gonna check the index value, and it's gonna concatenate based on the index value of each different data set. Now we observe 10 different value. We only have education columns and job columns, and we also concatenated with balance and duration. We are ready to go. And now again we use model selection dot train test split. Here we have x dataset and a y dataset, and our test size is gonna be 20%. Our training site is gonna be 80% of this dataset. This function assigns randomly. It just doesn't cut from the top, and just randomly assigns some row with this proportion. Now I am creating a logistic regression object, which is called logreg. This object has an attribute called fit, and I am just fitting my x values, all the features I have above, and my y value, which is no and yes. So now the predicted value, for predicted value I'm using predict attribute, and I'm gonna pass x test. So to be able to see what is the proportion of accuracy, like how many times I could make a correct guess compared to the whole number of data set, for whole number of rows, data points. So right now it looks pretty good. We picked a very good features. So we can say that the jobs and education level and balance and duration are pretty good estimators. So let's see what's happening with the confusion matrix over here. From the matrix, we are importing confusion matrix. Confusion matrix shows us the number of true positives, false negative, and true negatives. So for example, over here, let's say confusion matrix. So first value says C00, C01, C10, and C11. It means that the value was known as negative, and we found it's negative. That's a correct prediction. This one means the value was negative, but we predicted as positive. It was supposed to be a negative, but it's false positive. So for example, here it was supposed to be a positive, what we predicted as negative, which it means that false negatives, and this means that true positive, it was supposed to be a positive variable, and we predicted it correctly. So what was this? False negative, and this is true negative. All right, so this is what confusion matrix is over here. So this is the amount we predicted as correct, and this is also the amount we predicted as correct. As you can see, for many of the positive values we predicted as 0. So these are the coefficients of our logistic regression, and these from metrics we also want to see classification report with our prediction and a test value. Let me tell you what these terms mean over here. Let's go back here, and precision is equal to true positives divided by true positives plus false positives. It means accuracy of positive predictions. Is a score which can be given with this formula. It means that fraction of positives that were correctly identified. F1 score is a very helpful metric. F1 score means 2 times precision and times recall divided by precision plus recall. So if F1 score is close to 1, it means that the model works good, it works well. If it's close to 0, the model is not working to predict the best, to make the best prediction. As you can see, we predicted a lot of negative values correctly, but we couldn't make a prediction. We couldn't make a good prediction for positive values. One of the factors behind this is, for example, as you can see, there are a lot of no values, but there is only like 1/8 of these no values is just yes. So this is a very imbalanced data set.